Hi class, I've received this question regarding a problem in 6.3 practice assignment several times, and so I thought I would do hopefully a short video to help have it make some sense. This is the last problem in the practice assignment, and it deals with an airplane. It says an airplane, oh, and by the way, the one that I have on the image right here is just one that popped up for me. And in order to be able to see everything, I've had to show the completed problem. So just ignore the answers for right now. I'm going to show you the work behind getting those answers. So it says an airplane is asked to stay within a holding pattern near an airport. The function d of x equals 90 times the sine of 0.62x plus 190 represents the distance d in miles that the airplane is from the airport at time x in minutes. So even though the problem that you got might be a little bit of a different function, the setup is going to be similar. And one of the things I think that you should always do first, if you can, is to try and gain some understanding of what this function is telling you. And the way that it helps me to do that is by drawing a graph. In other words, we know a lot of information about the function d of x equals 90 times the sine of 0.62x plus 190, just because of our talk in chapter 5 about things like amplitude and midline and period. So I should be able to draw just a rough sketch of this graph. Let me move that up. So I'm going to draw my y-axis and I'm going to draw my x-axis. This is not on graph paper, so bear with me on this. My x-axis is x, and let's see, what did x stand for? X stood for minutes, so that's time. And then my d of x, what does d of x stand for? It tells me up at the top that d stands for distance in miles. So distance. And this is actually distance from the airport. And that's in miles. Okay. So let's see. Let me change pens. The 190 is my midline. So I'm not going to do a great job on, my focus is not going to be on labeling the axes as far as 10, 20, 30, 40, because that's not the point I'm trying to make here. And I could spend a long time just doing that. So I'm just going to put the 190 on the graph. And then I know that the amplitude of 90 is going to make me go up 90 and it's going to have me go down 90. So if I take away 90 from 190, that's going to put me at 100. And then if I add 90, that's going to put me at 280. Okay, so that just gives me a border for if I want to actually try and do a graph of this sine curve. I'm not going to be any higher than 280, and I'm not going to be any lower than 100. The only other thing that's given to me in the function is the 0.62, and that is my b value. Now what we know is that the period is equal to 2 pi divided by b, or I could say 360 degrees divided by b. It shouldn't matter, but I'm going to use 2 pi, and I'm going to say 2 pi divided by 0.62. And if I put that into my calculator, and I went ahead and, let's see, I'm not going to show you my calculator, but I know you guys can plug that in. I got 10.13. And so that represents, let me just go along the x-axis. That says that every 10.13 minutes, I'm going to see the curve repeat. So if I were to go out here and do another 10.13, that's going to put me at about 20.26. I'm going to see a repeat as well. Now let me show you what I mean by a repeat. It is a sine curve and there isn't a shift. Now what I know about a sine curve is that at zero, I'm at the midline. And then I see that midline again at the end of the period, and I see that midline again in the middle. So this is about, around 5. I know it's not exactly 5, but like I said, I'm not going to focus too much on the labeling of the axes. And in a sine curve from that midline, I'm going to go up to the maximum. So it's going to go up like this, and then it's going to go down, right? And then it's going to do something like that. And then, of course, the pattern just repeats. I hope that that makes sense. This is a review of really section 5.4. Okay, so something like that. So now we have a little bit of a visual, I hope, of what's going on. So question A says, when the plane enters the holding pattern at x equals 0, so that's right here at the origin, I'm circling that, how far is it from the airport? And you can see that the answer is 190 miles, and we can visually see that on our graph as well. Now, if we hadn't graphed it, then what we would have been doing is they gave us x equals 0. Let me move that up. They gave us x equals 0, and so I simply would have been finding what is d of 0, and that would have been equal to, let me just erase part of this. Can I do that? Hold on. There we go. D of 0 would be 90 times the sine of 0.62 times 0 plus 190. And so 90 times the sine of 0 plus 190. Now, what is the sine of 0? At 0, and I guess, I said, let me just go back here for a second. Up when I was talking about the period, I said something about it could be 360. The only way that this could be 360 degrees is if there was something in here indicating to me degrees. And because there isn't a degree symbol, then I'm gonna that's reason for me to use the 2 pi, because radians are unitless, just like that. What I see on the inside of the parentheses is unitless. So I am going to be in radians. The sine of 0 radians is 0. And I end up with my 190, and of course that was in miles. Okay, now part B. This gets a little bit trickier. And before I go to the algebra of it, and I know a lot of you didn't do algebra, a lot of you just graphed this in Desmos, and I can show you what that looks like here in just a second as well. But even if you do it in Desmos, I mean, that'll show you, I hope, what the answer is. But you should also be able to do this algebraically. That's really the point of section 6.3. Part B says during the first 20 minutes. So I want to just point out to you that I'm going to change maybe to, if I can, a highlighter. Can I do a highlighter? Oh yeah, look at that. So there's 20.26. Now what I know is that that graph just keeps on going, but I'm only going to be interested in that first 20 minutes. And what this wants to know is during the first 20 minutes, at what time is the plane exactly 130 miles from the airport? Well, 130 miles is about right here. Okay, about 130 miles. I'm on that d of x axis. And so if I draw another line through here, I can see that it's hitting exactly 130 miles at whatever that point of intersection is, this one, and this one. So there should be 4 answers. And of course, we can see up here what those answers are. Now, if you use Desmos and you input the d of x function, and then you also input y equals 130, and you click on that graph, it's going to give you the 6.24, the 8.96, etc. If you haven't tried that, let's see, maybe I can show you that real quick. Let me put a browser in here, and I'm going to open up Desmos, and let's see here. I'm not used to using without a keyboard, so bear with me on this. Y equals, and it was 90, and I need a function, the sine of 0.62x. Did you see what I did wrong there? I forgot the 6, or I didn't forget it, it just didn't type. 0.62x, and then plus 190. Now, the reason I can't see it is because if you look at my y-axis, it's only going to 10. So I'm going to have to adjust that here in just a second. Let me return, and I'm going to put in y equals the 130. 130. Oops. 130. There we go. All right, now let me just use my fingers here to zoom this graph in. Do you see it there? Okay, there it is. Now pay attention that I'm only interested in values that are, let me get my pen, that are between 0 and 20. So let me see if I can just make this a little bit bigger. Do you see 20 down here at the bottom? There's 20 and here's 0. So now I'm going to just tap on this. Tap. I don't know if I can do this. Can I do this on my iPad? You know what? It's not going to let me tap. Darn it. Hold on one second. Oh, there it is. I got it to work. And if I click on that point, there's the 6.24. There's the 8.957, there's the 6.378, and there's the 19.091. Anything beyond that, though, is bigger than 20. So yeah, it is hitting that 130 miles away at various points, but we're only interested in the first 20 minutes. Okay, so there's the answer on Desmos. And let me now, can I get rid of that? All right, then I'll make it real small and I'll just move it off to the side. And let me go back to this. Okay, so now I'll just put that off to the side and we want to come back to it. Now what I want to do is show you how to do this algebraically. So what I'm going to do is I'm going to set that function 90 times the sine of 0.62x plus 190. I'm going to set that equal to 130. Okay, and I'm going to solve. So I'm going to subtract 190 from both sides, right? I'm going to get rid of the 190, and then of course I'm going to divide by 90. I'm going to do all that. I don't need to write all that out. This is not a Math 60 class, so bear with me on that. I think you guys can do that in your head also. I'm going to get something like negative 60 over 90. And of course, negative 60 over 90 is negative 2/3. So now what I want to do is I want to get this 0.62x by itself. And I can get rid of the sine function as long as I take the sine inverse of that whole side. But if I do that, then I also have to, and let me just, where's my eraser? Let me erase, because here's what I want to show you. I want to show you good notation on this one. I'm going to take sine inverse of negative 2/3. Notice I don't want to squeeze it in there. I want to actually write it next to the negative 2/3. And it is really important that it's the sine written first and then the sine inverse of what you're taking. All right, so what is sine inverse of negative 2/3? Well, let's see here. Can I get back to Desmos? Let me go back to Desmos. Here it is. Can you see that okay? So I'm going to just type in here function sine inverse of negative 2 divided by 3. And you see that the answer I get, we know from our work with inverses in section 6.1 and 6.2, it doesn't surprise me that I'm getting a negative 7 or negative 0.73, because remember, for sine inverse, we're always getting an answer from pi over 2 to negative pi over 2. And so that's why it's writing it as a negative angle. So let me just make this smaller again. And remember that, negative 0.73, negative 0.73. So I get negative 0.73 as an answer. But I want to remind you of something. What we're talking about on this step right here is, what we're asking is what angle produces a sine of negative, excuse me, let me redo that. Produces a sine of negative 2/3. And you're only going to see a negative sign in quadrant 3 and quadrant 4, right? Think about that for a second. And so it doesn't surprise me that I'm seeing this result that the calculator gave, because that is an angle that's in quadrant 4. Can you visualize that? Can you visualize that? Let me just do a little circle here for you. Right? Where is, I know it's not a great circle. Negative 0.73 is starting on the positive x-axis and it's going clockwise. How much clockwise is it going? Well, remember, all the way around is 2 pi, which is 6.28. Halfway around is pi, which is 3.14. A fourth of the way around is pi over 2, which would be 1.57. So this going a quarter of the way around going clockwise is negative 1.57. So does that help you see that negative 0.73 is probably, somewhere about right there? Okay. Now, the angle in the third quadrant is going to be, I could write it as a negative angle as I wanted to, but I'm going to go ahead and just write it as a positive angle. And that brings me to another good point. The calculator gave me negative 0.73, but of course, if I want, I could add 2 pi to this, and I could express that negative 0.73 as a positive angle. It's going to give me the same answer. Okay, that may seem confusing, but you should try it on your own. My other angle is going to be 180 degrees, or pi radians, plus whatever the reference angle was that the calculator gave me. Now that reference angle is 0.73. So my second angle comes from taking pi and adding 0.73. That feels a little bit confusing even as I say it out loud, but what I tell you in the notes is that in order to find the other angle, you're going to take, for sine, you're going to take pi and you're going to subtract from that whatever the calculator gave you. If you look in your notes for section 6.3, you'll see that. I hate to have you memorize more things, but that is there if you want to. What I'd rather have you think is, okay, well, the calculator gave me negative 0.73, and I know that that's in the fourth quadrant, and I know that I also need a third quadrant angle, and so whatever this reference angle is for this one, that sign's going to be the same. So I have to take pi and I have to add that reference angle. Notice that taking pi and subtracting negative 0.73 is the same thing as adding 0.73. Okay, so put into your calculator pi plus 0.73, and let's see, I think I did this earlier for myself. What did I get? I got 3.87. So here's where I'm at. I've got 0.62x equals 3.87. I've got 0.62x equals negative 0.73. Okay, and now I'm going to solve for x. I'm going to divide everything by 0.62. And I'm going to get, let's see, 3.87 divided by 0.62 gave me 6.24. And then I also over here, negative 0.73 divided by 0.62, I got negative 1.18. Now you should be thinking to yourself, okay, I'm confused because Wendy said that there were 4 answers and I'm only seeing 2 answers, and only one of those answers, the 6.24, is one of the answers. If you go all the way back to the beginning, there's that 6.24. How in the world do we get the other ones? Well, let me remind you that 6.24 is just one possibility. We saw in the little sketch of the graph that we did. Let me erase this. We saw in the graph that we did that the period of this function, what did we say that it was? The period was 10.13. So what I know is that 6.24 is an answer, but if I add 10.13 to this, I can get another answer. And if I add 10.13 to this one, I can also get another answer. So what is 6.24 plus 10.13? And when I add those together, I think I get 16 well, it looks like 37 here, but if you use your calculator and you don't do any rounding in between, I think I got 16.38. And 16.38 is definitely in that range or that domain of 0 to 20 minutes. Okay, so here's an answer and here's an answer. Let me go up here, 16.38, one of my choices. Yeah, there's 16.38 right there. Now let's go up here and say, okay, well, what is negative 1.18 plus 10.13? And when I did that, I got 8.96. Is 8.96 one of my answers? Let's look. Sure enough, there is 8.96. And then there's one more. Well, remember, that 10.13 doesn't happen just one time. It keeps on going. Every 10.13 minutes, we're going to see that distance. So if I add 10.13 again, as long as I'm under 20 minutes, I should still use that as an answer. And when I did this, I got 19.09. And 19.09, I think we'll see here in a second, is it up here? There it is. There's the 19.09 minutes. That is one of my solutions. Okay, so that's how you find those solutions. And then the second part says, okay, well, we don't want to know when it actually equals 130. We want to know when is the plane more than 130 from the airport. Well, going back to, you can either go to the decimal screen or you can look at my little sketch here, because we now know, let me use a green pen, we now know these points that are circled in black. I know that this point right here is 6.24, and I know that this point is 8.96, and I know that this circled one is 16.38, and I know that this one right here is 19.09. So where am I more than 130 miles from the airport? So, that's wherever I am above that line, y equals 130. So it looks like it's happening from an x value of 0, and I'm above until I get to 6.24. So that's what this part right here is about. And then once I hit 6.24, oops, right there, then I dip below. I'm actually within 130 miles. And then once I hit 8.96, all the way until I get to 6.38, right here, I'm again above it. And then I dip below until I get to 19.09. And because we're limiting ourselves to the first 20 minutes, that's why that thing stops at 20 minutes. Okay, those were the biggest questions that I saw, and because I've talked for now almost 23 minutes, I think I'll stop this video. If you have any other questions or I didn't make sense, at least we've got a place to start with. One thing that's really helpful to me when you do ask me questions is if you take a snapshot of the work that you've already done, then I can see what you've done and I can fill in the gaps instead of starting from the beginning. Hope that helps. Hope you guys are staying warm. Have a good rest of your weekend. Bye-bye.